get started on law of sines. And all that is, it's going to be a way where we are going to be able, in certain situations, it doesn't work for every situation, we will have another law of cosines to finish the job. But law of sines allows us to, with given information, to solve triangles. And if you'll notice, the angles are the capital letters, the B, the C, and the A. And opposite side of angle A, I use the lowercase a, lowercase b here, and lowercase c for the opposite side of angle C. So that's just a convention for getting this done. Now, the law of sines, if I take the length of this side here and make a ratio with the sine of angle A here, then my pencil just broke. Alright, either I'm going to have to start this video over again. Pause. Alright, I'm back. I forgot I had that pause button I could use, so I got a pen instead. But as we were saying, the length of this side over the sine of this angle, those are equal for each side and opposite angle, or the sine of the opposite angle. So the length of this side over the sine of this angle is equal to also the length of this side. And it's that simple. So that's all we got to do when we're solving these. So I have a few examples for you. And the first example here is an angle side. It's solve the triangle for which angle A is 30 degrees, angle B is 45 degrees, and little a is 32 degrees. So I kind of like to draw this a little bit. Let me draw angle A. Let's set it's 30 degrees. So I'm going to put about like that. And angle B is, I'll put B here. So I'll put A here, I'll put B here, is 45 degrees. So I'll go more out like that. And my angle may look something like that. But this is 30 degrees here. This is 45 degrees here. And little a is right here, and it is equal to 32 centimeters. And it says solve the triangle. So we want to know what little b is, we want to know what little c is, and we want to know what angle C is. Well, angle C will probably be the easiest to get. 30 plus 45 is 75, and I know all three have 180. If I subtract 75, I know this is a 105 degree angle. And then all that's left is to figure out, and I think I'll start with this one, that 32 over the sine of 30, that is A over sine of A, angle A, equals, and let's go for B next. I'm going to put B up here, that length, over the sine of 45 degrees. And then the cross products are equal. So if I do this, B times the sine of 30 degrees is equal to 32 times the sine of 45 degrees. And then I'll go through and I'll divide by the sine of 30 degrees here, and divide by the sine of 30 degrees here. And B is equal to, alright, I'm going to check something I haven't, yet we're in degree mode. So I'm going to take 32 times the sine of 45 degrees divided by the sine, I'm doing this outside as you can see, of 30 degrees. And I'm getting, and let's go two decimal places when we're doing this, 45.25, and this is a length, so this is centimeters. So I'm going to put 45.25 centimeters. And then, over the 105 degree opposite side there, I got to do the law of sines again. So I've got this. I'm going to go for this C here. We found this. We have found this so far. We just have to find this side. And I'm going to start with the original that we had using the A. 32 over sine of 30 degrees is equal to C over the sine of 105 degrees. Okay. Feel free to pause and work ahead if you think you know what you're doing. But as I set that up, I'm going to go C times the sine of 30 degrees. This cross product is equal to this cross product. 32 times the sine of 105 degrees. I'm going to divide by the sine of 30 degrees here. I'm going to divide by the sine of 30 degrees here. And I'm going to take 32 times the sine of 105 divided by the sine of 30. 61.82. So C is 61.82 centimeters. All right. So we needed to find this side, and that angle, and we did, using law of sines. Hopefully you could see that. Now, example 2. This is, oh, I didn't point out, if you look at the information we were given back in your geometry days, we're not doing proofs here, but we are talking about, we were given 2 angles and a non-included side, not this side here. This time it is, we're going to be given 2 angles and the included side, the side that is between the 2 angles. All right, now, ooh, degrees and minutes are back. So I'm going to put B right here. 51 degrees and 45 minutes. So let me kind of go out like this and come up like this a little bit. And let me put C right here. And it would kind of go out about like this, I would say. I don't know why these all look alike. And I'm putting A up here. This is 13.1 miles. Now, do you remember degrees and minutes? I'm sure you do. Wrong device there. I'm going to take 45 divided by 60, and that's 0.75. So angle B is a 51.75 degree angle, and 30 divided by 60 is 0.5. This is a 47.5 degree angle. And I guess the first thing I'm going to do is go for angle A. This time we'll use the calculator. 180 minus 51.75 minus 47.5 equals 80.75 degrees. And now we've got this side, we've solved for that. We need to figure out what C is here and what B is here. So let's, now that we have an angle on opposite side, let's go ahead and set that up. 13.1 miles over the sine of 80.75 degrees. That equals, let's go for B, over 51.75. It's become very close to what we had before now. And let me do the cross products. B times the sine of 80.75 degrees equals 13.1 miles times the sine of 51.75 degrees. And I'm going to divide by the sine of 80.75 degrees here, and by the sine of 80.75 degrees here. So when I get B, I will take, let me get it all set here, 13.1 times the sine of 51.75 divided by the sine of 80.75 and get 10.42. B is 10.42, and this is miles. And I'm going to use the law of sines one more time to get C. And that would be, I'm going to use this 13.1 miles over the sine of 80.75 degrees equals C over the sine of 47.5 degrees. Wondering if you know, relative, just if you were to estimate, relative to the 13.1 miles and the 10.42 miles, how long do you think that side would be? I'm going to let you think about that, and let's calculate it. So the C times the sine of 80.75 degrees equals 13.1 miles times the sine of 47.5 degrees. And then divide by the sine of 80.75 degrees. And C would be 13.1 times the sine of 47.5 divided by the sine of 80.75 degrees, 9.79. Okay, so it's fairly close to that, but it is the shortest side. It's opposite this smallest angle too. Is that a coincidence? Okay, example 3 is we're given two sides and not an opposite angle. Well, yes, an opposite angle, but two sides and not an included angle. This isn't SAS. Okay, so angle A is 31 degrees. Let me kind of draw this. This is A right here. 31 degrees. Let me say that's about 31. Okay. A is 12 units long, and if I put B out here, let me just go right, make that a little shorter just to kind of make it look right, a little more right. So that's 12 inches. This is A. B here is 5 inches. And C is here, and C is here, and we know this is 31 degrees. So I've got the drawing made. And let's start with the two we know that are opposites. let's put the 12 inches over the sine of 31 degrees. And that will equal, now we got the 5 inches here, the 5 inches over the sine of B. All right. So, I'm going to do this one first. 12 times the sine of B is equal to 5 times the sine of 31. And I'm divide by 12. And I got the sine of B is equal to, now, inverse sine, which is what we're going to have to do, is a very sensitive measurement. So I'm going to go 4 decimal places when I do that. So I'm going to take 5 times the sine of 31, close that, and divide that by 12, and get, I'm going to use 0.2146. Now, to get B, I need to take the inverse sine of both sides. So I'm going to take the inverse sine of this, and that just gives me B there, and the inverse sine of this. So I'm going to go second and sine. Now, I could type in 0.2146 and be pretty close to what this is. I also think I still have access to that answer, so I'm just going to use the answer there. I hit second and then the negative sign, and get 12.39. And B is an angle, so that is 12.39 degrees. We just solved for an angle here. 12.39 degrees. And now I don't need to solve for an angle again on this. I can take 180 minus 31 minus 12.39 and get 136.61 degrees. And so C is 136.61 degrees. And okay. Now we got to get little c here. And that will be, let's see, let's do 12 over sine of 31. We know everything's in inches, so I'm not going to write that down now. Equals c over the sine of 136.61 degrees. And c times the sine of 31 degrees equals 12 times the sine of 136.61 degrees. I'll divide by the sine of 31. Divide by the sine of 31. And I'll get c is, I'm going to take 12 times the sine of 136.61, close that, divided by the sine of 31, 16.01. So C is 16.01 inches. All right. You guys take care.